Before you watch this video, make sure that you were in class or have gotten the notes for the sum and difference for sine and cosine, because a lot of the strategies are going to be the same, just with new identities. So in class we did the sum and difference formulas for sine and cosine, and now we're going to do the same thing for tangent. And as with the sine and cosine formulas, there's a pattern to them. So if you want to take two angles and add them together right there, and then evaluate the tangent of that new angle, then I want you to notice that the sign that's in here, it says the angles are being added, is the same sign that occurs here, and it's the opposite sign here. So if the two angles are being added, then the tangent values on top are added and the values on bottom are subtracted, which means the opposite's also true. If the angles are going to be subtracted before you evaluate tangent, then there's going to be subtraction in the numerator and there's going to be addition in the denominator. Now remember, you don't have to memorize these identities, but the more familiar with them you can become, the easier it gets for you and the less time it takes for you. So if I wanted you to evaluate the tangent of angle A plus B, okay, this right here is set up like it should be a picture drawing problem, but the identity for tangent of A plus B doesn't require that I know where my angle is, because it just uses the tangent values. Tangent of A plus tangent of B over 1 minus tangent A times tangent B. And I was given both of those numbers. So I was told that the tangent of A is 1/3, and so that's going to replace tangent of A here and here. And so I put a 1/3 in there, and I put a 1/3 in there. And then I also know that the tangent of B was 1/2, so it replaces tangent of B there and there. So I put a 1/2 there and a 1/2 there. Now remember, we're not just replacing angle A and angle B. I'm sure that's a point that we will make for sine and cosine and all the other identities. We're not plugging in angles to this, we are plugging in the tangent values to this. And now there's two ways that we're going to talk about how to simplify this. Method one for simplifying this answer is to just follow PEMDAS. And so in the numerator I would need to take this 1/3 and this 1/2 and give them a common denominator. So this would become 2/6 and this would become 3/6. So in the numerator I would have 5/6. Okay. In the denominator I would follow PEMDAS again. I would multiply these two things together first, and they don't need a common denominator to do that. It would just be 1 times 1 on top and 3 times 2 on bottom. And 1 minus 1/6, if you need to, you can turn this 1 into a 6/6, and you get 5/6. And then technically I could multiply by the reciprocal because I'm dividing by a fraction, but I don't need to, because any number divided by itself is automatically 1. Okay. Now the other method for simplifying this is one we've been using since back in September. So let's say I had that same fraction. So I had all my numbers plugged in, and I wanted to simplify my answer. Okay? And remember that whenever you want to get rid of little fractions that are embedded throughout a big fraction, you multiply through by whatever your common denominator is. And so I look at all these little mini fractions, and my common denominator for them would be a 6. So I've got to multiply through by a 6 on top and multiply through by a 6 on bottom. So when I take that 6 and I distribute to the first part of the numerator, 6 times 1/3 is 2. Then I distribute to the second part of the numerator, and 6 times 1/2 is 3. No more fractions on top. Then when I take the 6 and I distribute to the first part of the denominator, I get 6. And when I distribute to the second part of the denominator, remember these are already a single term because they're being multiplied together. So the 6 just cancels out the 3 and the 2 in the denominator, and I'm just left with a 1. And so on top I have 5, and on bottom I have 5, which still gives me the same answer of 1. Okay, so there's two ways of evaluating that and simplifying your answer. But the result is the same, that the tangent of angle A plus B is 1. Okay, now we don't know where angle A and B were, so there's actually no way to check this. If we knew where angle A and B had been, because they could have either been quadrant 1 or quadrant 3, then what we could have done is we could have, if we really insisted on checking it, we could have done inverse tangent over here, find angle A. Then we could have done inverse tangent over here and find angle B. And then we could have actually added them and then taken the tangent value. But in this unit, checking your work in a lot of these situations is more work than actually just solving it. So you're better off just solving it and simplifying it than you are trying to check all of your answers. So these won't need a calculator part, like the picture drawing problems in the last unit. Okay, so same identity, tangent of A plus B, so this is A plus B. And so now I'm going to just plug in different names for A and B. So according to this identity says tangent of A, well this time A is theta, plus tangent of B, and this time B is pi, and then 1 minus, and then tangent of A, once again A is the theta, times tangent of B, which is tangent of pi. And so this time around what we've got is we've got an identity where, let me change colors so it stands out, where a portion of it, this portion right here, has to be given to you. It is essentially the equivalent of being given the numbers from a picture drawing problem. And it's combined with tangent of pi, which is able to be evaluated just from your unit circle. So we're actually able to combine our picture drawing kinds of numbers with our unit circle kinds of numbers. So I'm going to go ahead and substitute tangent of theta right there is 2/3 plus, and then tangent of pi is just 0. And then tangent of theta is 2/3, and tangent of pi is 0. And so I don't need to deal with either of the methods that I had in the previous problem because my numerator is just 2/3. And 2/3 times 0 down here is just 0. And so my denominator is just 1. And so my answer is 2/3, which if you really think about it should make sense because tangent repeats itself. It gives the same answers every pi. So whatever tangent value theta had, add pi to it, you're going to get the same tangent value. Okay, it's just harder to visualize when you're combining unit circle and non-unit circle numbers. Okay. So the third example, it looks like I'm giving you the same kind of problem, which seems repetitive, but I want you to see what happens because there are times when this identity won't work. So this is still tangent of A plus B. Okay, so I'm going to go ahead and I'm going to write in my A and my B. A is theta plus tangent of B, and this time B is pi halves. And some of you may already be recognizing what our problem is going to be. Plug in tangent of theta, so tangent of A again, times tangent of b, which is pi halves. Okay, and hopefully even more people are recognizing now, tangent of pi halves here and here, tangent's undefined at pi halves. And so what that means is that you have some number plus undefined, and then you have 1 minus some undefined product. You can't evaluate it. But that doesn't mean it can't be done. It just means that it can't be done using this identity. So what we would do instead is we would take that tangent of a plus b, and we would use the original, the most essential definition of tangent, is that tangent is sine over cosine. So if it's tangent of these two angles added, it's going to be sine of those two angles added over cosine of those two angles added. Okay? And now I can actually go ahead and evaluate it. It's going to look like it's going to be this horrible long mess, and it's going to start out that way. But it's going to really simplify very, very quickly. So up on top here, I'm going to use my identity from in class. I'm going to do sine of a plus b. Okay? And so when I do that, the identity for sine of a plus b says sine of a cosine of b, and b in this case is pi halves, plus cosine of the first angle, so cosine of a, times sine of b. That's just the numerator. So like I said, it's going to look like it might be a huge mess, but it'll simplify here in just a second. And then down here in the denominator, I'm going to use the identity for cosine of a plus b. And that identity says to do cosine of your first angle, so theta, times cosine of your second angle, which is pi halves, minus sine of your first angle, sine of your second angle. Now, at this point, you have two options. Option one, right here. I'm going to start evaluating. I'm going to start plugging in numbers. So I can do it for all 8 parts. I could do sine of theta, cosine of pi halves, cosine of theta, the whole 9 yards. All 8 parts. Okay? But if I'm going to do that, then I need a picture. That's why we were told where our angle existed. We were told it was a quadrant 1 angle, because I would need to be able to figure out what sine of theta and cosine of theta and all of those are. Okay? Which is fine. That just means you draw a picture in quadrant 1. You were told the tangent value was 4/5, and you can do the whole 9 yards. Okay? But you don't have to, because if I just evaluate the unit circle parts of it, this is what happens. So I'm going to ignore the sine of theta for right now. Okay? But cosine of pi halves is 0. And I'm going to ignore the cosine of theta right now. And the sine of pi halves is 1. And same thing down here. Ignore the cosine for right now. But here, cosine of pi halves again is 0. Oh, I got ahead of myself. And then minus, and then ignore the sine of theta for right now. And sine of pi halves is 1. So look at what's going to happen. Remember, I said it was about to simplify really drastically. This becomes 0, and this becomes 0. Okay? And then this part right here, cosine of theta times 1 is just cosine of theta. And then I have my minus sign in the denominator. And sine of theta times 1 is sine of theta. And cosine over negative sine is negative cotangent of theta. Now the reason that helps us, we don't have to do this whole picture drawing part over here, is up here at the top, we were given our tangent value. So if tangent is this number, then negative cotangent means just take this number, flip it over, and make it negative. So negative 5/4. Okay, and so that is our answer. Okay, or you can do a picture drawing and you can find your hypotenuse and you can do your cosine and your sine and evaluate all 8 parts of that. Okay, and now the final problem is easier. What you want to do is, this equation looks like it would be hideous to solve because it's all tangent, but it's 2 different tangents. It's tangents of one angle and then tangent of another angle, and so you still couldn't solve it because it's still technically 2 different trig functions. Okay, and so what we would do is we would match it to an identity, and we look at the sign here. They're being subtracted, and that tells us which tangent identity it matches to. It matches to tangent of a minus b. And this was what was plugged in for angle A, and that's what was plugged in for angle B. So that's what we do, is this is what we call the long side of the identity. And I've got angle A plugged in both places and angle B plugged in both places. So what I'm going to do is I'm going to take those same angles and plug them into the short side of the identity. It's just identity matching, essentially. And so angle A was what they called 3x minus, and angle B was what they called x. And that takes the whole left side, that was that hideous fraction, and it all of a sudden simplifies it. It substitutes or replaces it with something. And 3x minus x is 2x. And now we can solve this. Okay, and so just a reminder, this is something we've been solving for in a while now. I'm going to take the inverse tangent of both sides. It'll get rid of the tangent on this side and leave the 2x. And when I take the inverse tangent of this, I need to write it as a general solution, because this 2x right here is going to double my number of answers. So when I do inverse tangent, and I can go ahead and write it if that helps some people. So what I'm doing right now is I'm doing inverse tangent of the right side. And when I do that, I want to write it as a general solution. So the first angle that has that tangent value is 60 degrees. And tangent cycles every 180 degrees. So there's my general solution. And I wanted it written that way because my last step is going to be to take the whole equation and divide it by 2 or multiply it through by a half, because it's the same thing. And so what that means is that instead of starting at 60, I now start at 30. And instead of taking 180 to cycle to all my new answers, my answers will cycle every 90 degrees, which is going to generate more frequent answers. And so my answers between 0 and 360, my first one was 30, and then I just start adding 90 over and over and over again. So then I get 120, and then I get 210, and then I get 300. And remember, we knew how many answers we were going to have, because normally inverse tangent of square root of 3 would normally have 2 answers between 0 and 360. Well, this 2x right here doubled that number of answers, so that's why we have 4. Okay, and so now we're done with today's notes. So no more notes till next week. Remember that we're going to be giving you guys time to work in class on this. You just need to make very good use of time and ask lots of questions, check your answers, try and get as much done in class as you can. See you guys in class tomorrow. Bye.